Good morning everybody. Myself Dr. Arjyadhara Pradhan. I am going to teach you today about Thevenin's theorem. In electrical engineering there are many theorems and one such theorem is Thevenin's theorem. It is used to solve the complex electrical circuits. Other theorems are like superposition theorem, Norton theorems. In Thevenin's theorem there are three easy steps. Step number 1 is to find out V Thevenin. Step number 2 to find out R Thevenin. And step number 3 is to find out the equivalent circuit. Now what is Thevenin's theorem? Thevenin's theorem states that in any linear network bilateral circuit consisting of one or more dependent or independent sources can be replaced at a pair of terminals A and B by an equivalent voltage source in series with an equivalent resistance. So that equivalent voltage source is called as Thevenin voltage and the equivalent resistance is called as Thevenin resistance. So we will consider here one more point. When we are considering voltage source, it should be shorted, and when we are considering current source, it should be open circuited. In this regard, we will solve one problem by Thevenin's theorem and we will see how the circuit is simplified. So we will consider one problem, Thevenin's problem. So we will consider a circuit consisting of two voltage source, that is one voltage source is 9 volt and there are 4 resistances. Another voltage source is 6 volt. So the circuit goes on like this. So these are the 4 resistances which are also called as passive elements. It is 5 ohm, 4 ohm, 6 ohm and 10 ohm. So we have to find out current and voltage across 10 ohm using Thevenin's theorem. So going to the step number 1. So step number 1 is to find out V Thevenin, that is Thevenin equivalent voltage. So in this case I will consider one source at a time. So taking one source, that is my 9 volt source, I will neglect other source. As it is a voltage source, I will short circuit that voltage source part and I will redraw the circuit. So the 9 volt source will be redrawn and the figure grows like this. The voltage source will be shorted and whichever circuit or load resistance across which I have to find out current, that part I will open circuit it across a pair of terminals A and B. So I will look the circuit from this particular side. So here is my 4 ohm, this is my 5 ohm, this is 6 ohm. So voltage across A and B is same as voltage across CD, which is called as Thevenin voltage. So I need to find out voltage across CD. This particular branch I will give it as C and D. This is my 9 volt source. So current across 6 ohm resistance will be total voltage 9 volt by 5 plus 6, that is 9 by 11 ampere will be my total current flowing in this circuit. Now coming back to this circuit again, as this side is open circuit, whatever current will be flowing in this 5 ohm, same current will come to flow through this 6 ohm. Therefore voltage across CD, or we can say voltage, Thevenin voltage will be equal to 6 ohm into current 9 by 11, that is 54 by 11 volt, which is equivalent to 3.27 volt. Now I will consider source 2. Second source I will take, that is source, that is 6 volt source. So first voltage source will be shorted and then I will redraw the circuit and I will write it in this form. So the circuit goes on like this. It is 6 ohm, 6 volt, 5 ohm and then this is 4 ohm and it is open circuited A and B. So again I need to find out the current voltage across this CD branch. So total current across 6 ohm will be 6 volt by 5 plus 6, that is 6 by 11 ampere. So voltage across 6 ohm I will get around 6 by 11 into 6, that is 36 by 11, which is equal to 3.27 volt. Sorry, this is 4.908 volt. Now net voltage VCD across this branch will be 6 volt minus 3.27, that is 2.73 volt. Next I will find out step 2. Step 2 is to find out the Thevenin resistance. So for calculating Thevenin resistance, all the voltage source will be shorted and all the current source will be open circuited. So the circuit goes like this with 3 resistances, 4 ohm, 5 ohm, 6 ohm, and then now we need to analyze the circuit from A and B side. So we can say R Thevenin is nothing but 5 ohm and 6 ohm parallel with 4 ohm in series, and that we get a net value of 6.72 ohm. Next we go to the step 3, that's the last step in this theorem, equivalent circuit. In this step we have to do the final calculation, so we will consider here Thevenin voltage in series with Thevenin resistance, that is R Thevenin 6.72 ohm. This is V Thevenin, which is around combination of V Thevenin 1 plus V Thevenin 2, and then the load resistance, that is RL 10 ohm. Now net V Thevenin is nothing, it's a combination of two voltages from two Thevenin sources, 4.908 plus 2.73, which is a value of 7.64 volt. Now I need to find out current across, so total current will be equal to V Thevenin by total R, that is 7.64 by 16.7, which is equivalent to 0.45 ampere. Now current, same current flows across RL, which is equal to 0.457 ampere. Thus by Thevenin's theorem we have found out the current through the load resistance.